Good morning, everyone, and welcome to the lecture. This is EM waves, electromagnetic waves, lecture number 2. Well, in lecture number 1, we had seen the fundamentals of EM waves. EM waves means electromagnetic waves. When I say electromagnetic waves, what I mean is light waves. Light waves are electromagnetic waves. Do we know this? Yes or no?
Yes, sir.
Electromagnetic waves, that means that it consists of both what? Electric and magnetic fields. Do we remember this?
Yes, sir.
And these electric and magnetic fields are, how are they placed? They are placed how? They are placed perpendicular to each other. They are perpendicular to each other. Yes or no? No, yes?
Yes, sir.
Yes, they are perpendicular to each other. At the same time, they are also perpendicular to the direction of propagation of waves. Do we remember this? Do we remember this, bacha?
Yes, sir.
We had seen the fundamentals. Let me go back and show it to you once again. I hope you can recollect it. The last thing that we did was something known as Ponting vector. Do you remember Ponting vector? Ponting vector, S vector, is given by E cross B divided by mu. It's a very important relation that you must remember. Ponting vector represents the rate of energy flow, or you can say in simple words, it tells us the direction of velocity or the speed. It tells us the direction of propagation of wave. It tells us in which direction the wave is propagating. E cross B will give us the direction of wave propagation. Do we understand this? Yes or no? That
Yes,
is
sir.
one very important thing that you must remember. I hope you have noted it down already. Yes or no?
Yes, sir.
Okay. So this is what you must remember. Then comes two very important formulae, which are the formulae of energy density. What is this energy density? Now, whenever we use the term density, density means every time we use the word density, it will mean something per unit area, something per unit length, or something per unit volume. Here it is energy density, so it means it is energy per unit volume. Do we understand this? So energy divided by volume, or how much energy is stored in a unit volume, is known as energy density. Do we understand this?
Yes, sir.
Energy stored per unit volume. Electric field. In electric field also energy is stored. In magnetic field also energy is stored. What are the energy stored per unit volume in electric field and magnetic field? This is the formula for electric field. This is the formula for magnetic field. The formula for electric field is half epsilon naught E square. The formula for magnetic field is B square, where B is the magnetic field intensity by 2 mu naught. The total energy density, the total energy stored per unit volume in an electromagnetic wave. Wherever the wave is traveling, the energy is stored. It is stored in the form of electric and magnetic energy. The density of electrical field is half epsilon naught E square. The density of magnetic field is B square by 2B naught. Do we understand this? Yes or no?
Yes, sir.
I'll give you a minute to note it down, beta. Please note it down. Let's move ahead. Now, sometimes what they ask is not the energy density, they ask you the average energy density. If I take the energy density for a long interval of time, what is the answer? So the energy density taken for a long interval of time is known as the average energy density. The average energy density is half epsilon naught E naught square E square. Uh, E square was the value of electric field E naught square. The formula has changed here. It has become E naught square and B naught square. E naught is the amplitude of electric field. B naught is the magnitude of magnetic field. Do we understand this? Yes or no? No or yes?
Yes, sir.
So energy ka average will become half epsilon naught E naught square or B naught square by 2 mu naught. Do we understand this? Yes or no? No or yes?
Yes, sir.
I'll give you a minute to note this down. Very important formula. This formula number one, this formula number two. This is going to come many times in EM waves. Please note it down. That takes us to the next thing, which is known as electromagnetic spectrum. What do you mean by electromagnetic spectrum? It is nothing but when we arrange all these electromagnetic radiations according to their wavelengths or frequency in the increasing order of wavelength or decreasing order of wavelength or increasing order of frequency or decreasing order of frequency, that spectrum, that arrangement is known as electromagnetic spectrum. We have already gone through this once, but we will again see it because I have seen many times question coming in NEET based on this, which has a higher wavelength, which has a lower wavelength, which has a higher frequency, which has a lower frequency, and therefore you must not forget this table, and you must remember this table. I hope you can see this table, which has the lowest frequency, which has the highest frequency, starting from radio frequencies, which is the lowest one. Radio frequencies, V is equal to F lambda, remember? V is equal to F lambda. I hope you remember this. Yes or no? No, yes.
Yes, sir.
So you can arrange them in increasing order of wavelengths or order of their frequencies. I think there is something wrong in the table. So this is the correct table that you must remember. This is the correct table. Okay. On the top, what you see are the wavelengths. Do we understand this?
Yes, sir.
And on the bottom, what you see are the frequencies. Do we understand this? This is wavelength in nanometers. On the top side, this is frequency of this wave. As you can see, the largest wavelength is for radio waves, which has the lowest frequency. So, largest wavelength is radio wave. Then we have VH, very high frequency radio wave. Then we have microwave. Then we have infrared and the visible light. This is the small region of visible light. Do you see this?
Yes, sir.
Right? Then you have ultraviolet. Then you have X-rays. Remember, this is decreasing order of wavelength. And then you have gamma rays. Gamma rays has the highest frequency and the lowest wavelength. Do we understand this? Yes or no? No or yes? So this is from here to here. This is increasing order of wavelength. Now, if you understand one, the other one would be the reverse of this. Do we understand this? Yes or no? No or yes? I'll give you a minute to just write it, not from the table, to just write it in your own hands. Increasing order of wavelengths, lowest wavelength gamma, then X-ray, then ultraviolet, then visible, then infrared, microwave, pH radio wave, and radio wave. Can you do that for me, bacha? I'll give you a minute to do it. Okay, you have done this. Now remember a very important information, a very important formula. I don't know whether I have missed it or not. The relation between E naught and B naught. E naught is the amplitude of electric field and B naught is the magnitude of amplitude of magnetic field. E naught by B naught will always be equal to C. You can also write this as like this. E naught will be equal to C times B naught. What is C here, beta? C here is the speed of light, and the value of speed of light is 1 by root over mu naught into epsilon naught. These two formulas you should never forget, because straight away question will come from this formula. What is the relation between E naught, B naught? What is the value of C? These are the questions that are coming in exam these days. Mark them very, very important. Very, very important in your notebook. Do not write it in a sheet, mark it in a notebook. Well done. Now we move on to the next part of this chapter, which basically talks about the equations of electromagnetism. So we'll go through the equations in electromagnetism, and then we will see what happens with a correction in this equation. This correction and the equation was done by Maxwell, and hence the later part of the equations will be known as Maxwell's equation. So here we go with the basic equations of electricity and magnetism. Remember that this chapter is the last chapter of electricity and magnetism, but we are not doing it at last because we'll be doing EMI and AC after this. I did this before EMI and AC for the simple reason that we were doing wave motion and we were doing with wave equation. So I thought that wave, I would be able to relate it easily. That is why we did this chapter before. Anyways, coming on to the point, the four basic equations of electromagnetism, and these are the four equations that you will write one by one. The first equation is Gauss law of electrostatics, integral of E dot ds is charge enclosed divided by epsilon naught. Do we know this equation? Can I have some raise hand? Yes or no? This is Gauss law. B dot ds, we'll find the integral of B dot ds, which is the magnetic flux. That is Gauss law for magnetism. If you find B dot dl, that is Ampere's law for magnetism. If you find E dot dl, that is Ampere's law for electrostatic. Remember, these laws are true only for non-varying, non-time varying fields. These fields, whatever fields we are talking here, whether it is electric field or magnetic field, they should not vary with time. If they are varying with time, then these formulas are not valid because the formula changes. Do we understand this? Yes or no? No or yes? I'll give you a minute to note down these four. The formula that we did was for non-time varying field. What happens? How does the formula change if you have a time varying field? Well, that is coming on your screen right now. This is the formula for a time varying magnetic field as well. When electric field varies with time, remember this, when electric field varies with time, it produces a magnetic field. When electric field varies with time. It produces a magnetic field. This is what we are going to study in the next chapter, that is EMI. So everything is relating very nicely. This electric field that is produced, remember, this is non-conservative in nature. This electric field, this formula is only valid for a field, is valid for a field which is varying with time, and this time varying electric field gives rise to a magnetic field, and this electric field is non-conservative in nature. But if I compare it with the previous equation, in the previous equation what you had seen is E dot dl was equal to 0. Do we see this, bacha? This this electric field that we see here is conservative in nature. Please note it down. This electric field that we see is conservative in nature. In fact, this electric field is known as electrostatic field. This is not electric field, this is electrostatic field. This is conservative in nature. I hope you have noted it down. But the other field, the field that we are seeing right now, the equation that we are seeing right now is not valid for a conservative field. This is the time varying electric field which is non-conservative in nature. Have you understood this, bacha? Very important point. We are going to study about this field in the chapter of EMI. Do you understand this?
Yes, sir.
I'll give you a minute to note it down. Everything that I've done, which field is conservative, which field is not conservative, you should note it down. Then we move ahead and we see what happens. Well, when Faraday gave that law that a changing electric field, when I say changing electric field, I mean electric field that is varying with time. Then Maxwell tried to generalize Faraday's concept. So, if a changing magnetic field can produce electric field, that is what Faraday said. Maxwell said a changing electric field will also produce magnetic field, and that gives us the concept of displacement current. So, what is happening here in displacement current? Uh, if you have a changing magnetic field with time, that will create an electric field. If you have a changing electric field with time, that will create a magnetic field. So both of these things are happening together. Do we understand this? Yes or no? No, yes. That is what is known as the modified Ampere's law with the concept of displacement current. What happens in first case? Faraday gave us changing electric field. With time will give you magnetic field. Maxwell said, well, changing magnetic field will also give you electric field. Do we understand this? Yes or no? That brings us to the concept of displacement current. Please note it down, the concept of displacement current. Well, let's move ahead and see what was the original Ampere's law and how it has been corrected by Maxwell. As you can see, this one in the box, the blue box, is the original Ampere's law. Do we see it, bacha? Yes or no? This was the
Sir.
one that you have already noted. This IC is the normal current that you see, which is due to the flow of electrons. Do we understand this? This is known as conduction current. Therefore, it is written as IC. This is the original form of Ampere's law, which was already known. What Maxwell did was corrected it and he said, ki bhaiya, if magnetic field is changing with time, it will give rise to an electric field as well, and therefore there would be an electric flux that would change with time. And he gave this formula, this additional term for a changing magnetic field with time. This elect So changing magnetic field with time will create an electric field, and this electric field will give rise to another quantity which will be known as current. This quantity that you see here, E naught into d phi E by dt, is known as displacement current. This current is known as displacement current, and this is produced by the electric field which is produced by the changing magnetic field. This one is our normal current which is known as conduction current. So basically what Maxwell did was corrected this equation and added one more term to this equation. This term has come because a changing magnetic field with time will create an electric field. This electric field will have its own current. That current is known as displacement current. E naught epsilon naught into d phi E by dt is known as the displacement current. IC is your normal current which is due to the flow of electrons. Do we understand this? I'll need these hands from you to understand this. I'll give you a minute to note down. This is, you can say, original form. It only had conduction current, the original form of of Ampere's law. This is the correction that was done by Maxwell. He said no, a changing magnetic field with time will also produce an electric field, and this thing put together is known as the modified Ampere's law by Maxwell. I'll give you a minute, maybe 2 minutes, maybe 3 minutes to note it down. We have seen the original four equations. We have also seen that those original four equations are only valid if the electric and magnetic fields are not time varying. We have seen what happens when electric field is time varying, it produces a magnetic field. We have seen what happens when magnetic field is time varying, it produces an electric field. How can I combine all the equations and make them valid for time varying as well? That was done by Maxwell, and now it is known as the Maxwell's equation, which is valid for time varying as well. So now the first equation does not change. It remains same. E dot ds is q by epsilon naught. Second equation remains same. B dot ds, the integral magnetic flux is 0. The third equation has changed. In the previous one that we had seen, E dot dl ka integral was 0. Now it become minus d by d phi by dt. That was given by Faraday. A changing electric field with time gives rise to a magnetic field. The fourth one was integral of B dot dl is equal to mu naught I. Here they have added this term. This is known as a displacement current. And this current comes because of a changing magnetic field with time produces an electric field. Do we understand this? So do we understand the new form of the four equations? Yes or no? No, yes. Then write these four forms. These are the original form. Now the new form of the Maxwell equation. I'll give you a minute to do it. Do you understand this? Then we come to the next thing. Well, what happens in free space? There are no charges and there is no conduction current for free space. We can leave this conduction current. So for free space, we have this equation. The third equation remains same, but the fourth equation, there is no current. So the fourth equation, current goes away and whatever remains is this one. If I solve these two equations, and we don't have to solve it, Maxwell has already done it for us. We solve these two equations, we get the value of electric field and magnetic field. This is the value of electric field. This is the value of magnetic field. E naught by B naught is C, and 1 by root over mu naught epsilon naught is C. This is how we get these two equations. And once I get these two equations, I understand that electric and magnetic field are always going to coexist. If one way changes with time, other will come. If other changes with time, one will come. Do we understand this? Yes or no? No or yes? Please, please, please write this down. This is the entire concept of electromagnetic waves in one single shot. One single shot. Well done. Then we have finished the theory part of electromagnetic waves. I hope you remember what we have studied. I'll give you 5 minutes. One question, maybe even two, can come from this part. So I'll give you 4 or 5 minutes to go through this entire concept of EM waves, go through the entire sheet, because now when I come back, we will be solving some questions from the previous year. We will be solving some questions. And if you can do whatever questions I am doing right now in the class, I'm sure one question will come in the examination all out of this, and you will be scoring full marks in that. Give you 5 minutes, go through this entire thing. Any problem, anything, please ask me.
Sir, what is our next topic?
Let us move on to the next question, and the next question is this one. Displacement current is same as which one? Which is the correct option here? Displacement current is same as what? Can I have your answers?
D, sir.
It is not a conduction current, but it is caused by a time varying electric field. That is correct. So I hope you understand that the problems here are simply based on what we have learned, and if you understand those things correctly, the problem becomes very simple. Yes or no? Okay, let us move on to this one, and I hope you can see the question on your screen now. Can I have the answer for this one? The relation between electric field D and magnetic field B in an electromagnetic wave is what? Which one is the correct option? A, B, C, D. 1, 2, 3, 4.
B, sir.
B, E is equal to CV. I told you that formula. It's a very important formula. Most of the question that you will find will be based on this formula.
Yes,
That
sir.
is the next. Yes, beta.
Yes, sir.
This is the next one. An electric field, an electromagnetic wave is propagated along y-axis. Then what will happen? Please let me know. A, B, C, D. Question number 9. This is question number 9. EM waves is propagating along y-axis. Where are those things? Yes, beta.
A, sir.
Oscillating field is along x-axis and magnetic field is along y-axis. No, beta. Electromagnetic wave is moving along y-axis. Electric and magnetic field will be perpendicular to y-axis. Think again. Think again. Think harder. Wave is propagating along y-axis. Where will be our electric and magnetic fields? Think harder. You can do it. I can know. You can do it. Which one? The electric and magnetic
C, sir.
field will be along x and z axis. So the correct answer, yes, my dear friend, the correct answer has to be B. Do we understand this? Yes or no? No, yes.
Yes, sir.
So you have to be a little bit more careful, bacha, when you are dealing with questions of this nature, and that is why we are doing questions. Comes the next one, the Maxwell's equation. The Maxwell's equation. This is a statement of what?
Modified Ampere's law. B, option B, sir.
Very nice, very nice. I even could not finish the question and you could answer. Please keep the same spirit. Remember, remember that your exam is going to come very soon. If you can remember all these things correctly, we'll see what will happen. Next one. If we don't know this law and you don't know this law, This is definitely not Ampere's law, so you can use the elimination method. This is not Gauss law of electricity. This is not Gauss law of magnetism. So the only thing that remains is Faraday's laws of induction. Yes or no? No or yes?
Yes, sir.
Yes or no? No or yes? Tell me yes or no? No or yes?
Yes, sir.
And we will be doing this in the next class, in the next lecture. EMI, Faraday's law of electromagnetic induction, that is coming up, coming up, coming up, coming up. Do we understand this? How things are getting related to each other?
Yes, sir.
Yes, sir. No, sir. Better I'd go, sir. Next question, sir. A very important question that you must remember. It's based on the equations that we have seen for electric and magnetic fields. Question is right now on your screen. In electromagnetic wave, what is the phase difference between electric and magnetic fields? I'm waiting for your answers, Bacha. Look at the equation and give me the answer. Look at the equation, give me the answer.
0, sir.
Zero, they are in the same phase, remember, they are in the same phase. Please believe me, please trust me, they are in the same phase. We have already seen their equation and I will show them to you right now. We have seen the equation just now. The last thing that we did was we derived and we saw those equations. Yes or no? No, yes. These were the two equations that we saw, and remember, they are in the same phase. Do we understand this? Never forget this. Never forget this. They are in different axes, but they are in the same phase. Yes or no? No or yes?
Yes, sir.
Now this one. Let's see if I can give me this one.
Option B, sir.
Which option, which is independent of wavelength? Which of these is independent of wavelength? K, remember K was wave number 2 pi by lambda. Yes or no? No or yes?
Yes, sir. B, sir.
K by omega. K omega or omega. K by omega. K is 2 pi by lambda. Omega is 2 pi by t. Will it be independent of wavelength? Yes or no? No or yes?
Yes, sir.
V is equal to F lambda. Yes, it is independent of wavelength. This is what you see. Remember, there could be a confusion here that omega, which is 2 pi into F, is independent of frequency. But remember, V is equal to F lambda. V is equal to F lambda. The only thing that is constant is V. Speed of light is constant. This is an electromagnetic wave. This is not another wave. This is not a transverse mechanical wave. This is not a longitudinal wave. If this was a longitudinal wave, then the answer would have been angular frequency because it only depends on the source. Here, whatever be the source, the speed of light, the speed of electromagnetic field is constant. That is equal to C. There's only one equation that gives us lambda by T or lambda into F or T by lambda. That is K by lambda. Do we understand this? Yes or no? No or yes?
Yes, sir.
And that is why the answer is what we have seen. Next question is this one, asked in a different way. Can I have the answer for this one? This H is not a term that you have read, but it's also magnetic field. can I have to answer here?
C, sir.
Great. Have you seen this term before?
No, sir.
Whether it is C or whether it is B? Remember, E is equal to C into H, right? C into B. This is one formula that you must remember. Do we understand this?
Yes, sir.
Remember this always. Do not forget this. And remember this relation between E and H. Intensity of magnetization. Will you remember this?
Yes, sir.
Okay, great. One more of this nature. Same thing asked in a different way. An electromagnetic wave going through vacuum is described by E is equal to E naught this, B is equal to B naught this. Which of the following equation is correct? Remember the basic formula. To remember the basic formula, you will be able to answer this. Question number 14 is what we are talking about. Do I have an answer here? Is the answer coming anywhere? Okay, shall I give you a hint? Remember, E naught will be equal to C times B naught. Yes or no? I just told you that. And this C is equal to omega by K. Remember this formula for speed of light. Can you remember this for me? So now you can tell me which option is correct. C is 1 by root over mu naught into epsilon naught. That is correct. This is how you can find out C as well. Omega by K. These are different ways in which the same thing is asked. Do we understand this? Yes or no? No or yes?
Yes, sir.
Please note it down, beta. The question previously that I gave you, instead of B, it was given as H. All these questions are asked in the same way. They only depend on three formulae. If I call this formula as formula number 1, if I call this formula as formula number 2, and if I call C as 1 by root over mu naught into epsilon naught, this as formula number 3, all these three things are related like this. Do we understand this?
Yes, sir.
Please remember this. Please do not forget this. That will help you in finding out the values of all these three quantities. Only these three equations will give you what you require. One more. These type of questions are going to come and I will show it to you. Don't worry. Can I have the answer for this one? E naught by H naught. Again, you will say what is H naught? This is magnetic field only. Magnetizing field or magnetic field doesn't make much of a difference. The ratio of E naught by H naught for a plane electromagnetic wave has a dimension of what? Impedance, resistance, both, none. Okay, you don't know these terms right now, so let me not bring it now. Let me do it. Let me do this question. We'll probably go to that question afterwards when we are done with this. Okay. An electromagnetic wave going through a medium is given by this. Then, which is the correct option? Yes, beta. Is the first option correct? Yes or no?
Yes, sir.
Okay. Now remember, look at option B. This is in z direction and this is in minus y direction. That means your wave would be propagating in the x-axis. These both are perpendicular. Now, if this option was not given, some other thing was given, this option was somewhat different, then the answer would be A only. Here, if the answer is A, and then if the answer is A, then the option is also D. So A and D will become correct, right? But since a single option type question, so A and D cannot be the answer. Do we understand this? B
Yes.
alone cannot be the answer because A has to be the answer. So by that logic, remember A and B can both be the answers. Only A can be the answer. We cannot be very sure about B. Remember, magnetic field, electric field will be in perpendicular direction, but we cannot surely say in which direction they will come. So we have to be careful if such a question comes. Do we understand this?
Yes, sir.
One more coming here. The energy density of formula so that you can revise it. Which one? Formula for energy density. Yes, bacha.
D.
The option is G. Half epsilon naught E square plus D square by 2 mu naught. Do we understand this? Yes or no? No or yes?
Yes, sir.
Let me take one or two questions from the previous years as well. Electric and magnetic fields of an electromagnetic wave are, see,
Per, B, sir.
in phase and perpendicular to
B,
each other.
sir. B,
Yes,
B.
sir. D, sir. D, sir,
B,
no?
sir. Perpendicular to each other.
B, sir, or D, sir?
Yes, sir. You are correct, sir.
Okay, thank God I am correct. Do we understand this? Yes or no?
Yes, sir.
You understand this? Yes or no?
Yes, sir.
Okay, beta. Please don't forget it. We had done question. We had done two questions on many questions on this. What they have done is they have put both the questions together and they have asked you. Don't get confused. Don't get confused. Next one. Which of the following statement is false? I hope you can see the entire statement. And the answer is confused. And the answer is C. They are not parallel to each other, right?
Yes, sir.
Why it was taking so much of time, bacha? Why it was taking so much time, beta? Do you understand this? Yes
Yes,
or
sir.
no? No, yes? Okay. One more. The electric and magnetic field associated with an electromagnetic wave propagating along plus z axis. Plus z axis. plus z-axis can be represented by, it is along z-axis, so electric and magnetic field must be along x and y. Yes or no? Yes or no? Say yes or no. Electric field and magnetic field must be perpendicular to the direction of propagation of wave. Wave is moving along z-axis. Yes or no?
Yes, sir.
So electric and magnetic field must be along which axis or which plane? Tell me. They must be along x and y planes. So option number A and C goes. Remember, I vector is along x-axis. Do you remember this?
D, sir.
D, sir, I cross J is K. That is correct, sir. That is what I was waiting for. I cross J is K. Do you remember it, sir?
Yes, sir.
That is what you need to remember, sir. One question and then we will call this topic bye-bye. Say bye-bye to this topic. Again, as I told you, I asked you to write the order. Yes or no? No or yes?
Yes, sir.
Do you understand the reason why I've asked you to write the order?
Yes, sir.
Now give me the answer, sir. If you don't give the answer, that means there is no point of writing the order. This is decreasing order of wavelength.
Sir, it's definitely B, sir.
Definitely be, sir. No doubt, sir. You would not know this question if you don't write it, sir. Do we understand that, sir?
Yes, sir.
That is why I'd asked you to write this question down, to note the order down with your own hands, and that brings us to an end of EM waves. We have covered almost all questions that can ever come in an exam, whether it is JEE or NEET or anything. They cannot ask you beyond this. And they would ask at least one or two, maybe two, if you are lucky enough. Two questions or one question from here. Well, that's it for this lecture. And I'll give you 5 minutes. And then we'll be back with the next lecture. The next lecture is on EMI. I'll be back. Okay.